Hello everyone. Welcome back to another tutorial in this COVID-19 pandemic season. Students, thank you very much for being kind to your parents at home. Parents, I hope you're taking a well-deserved break during this Easter holidays. Thank you very much for what you have done so far. It is very much appreciated. Thank you. Today we're going to be looking at long division. And we're going to be focusing on doing or using the factoring method. Now, before we go into what is the factoring method, I wanted to remind ourselves of how to do division with single digits. So here, if we're going to look at dividing the number 528 by 6. 6 into 5, I can't, so I put my 0, put my 5 there. 6 into 52 is going to give me 8 times, because 6 times 8 is 48. I'm going to have 4 left over. 6 into 48 is 8. So it's going to give me 88. So that's just a reminder of how to do division with single digits. This is the method we're going to be taking in to do when it's dividing by double digits. The two words I want to focus on today is the word factor and prime numbers. Factors and prime numbers. So I want to focus on factors and prime numbers. What is a factor? A factor is a number that can divide another number without leaving a remainder. So a factor is a number that can divide another number without leaving a remainder. So if I should look at the factors of 1, the factors of 1 is just 1. There's no other number that can divide 1 without leaving a remainder. Factors of 2, 1 and 2. Factors of 3, 1 and 3. Factors of 4, 1 times 4 is 4, and 2 times 2 is 4. I don't have to put them in order. It's easy for us to remember it if we try to pair them. So it's 1, 4, 2. Or if we want to put them in order, we can say 1, 2, 4. Factors of 5, only 5 times 1 gives 5. So I have 1 and 5. Factors of 6, I can say 1 and 6, and I can say 2 and 3. Now, we do not need to learn them in order, but if you wanted to write them in order, you could say 1, 2, 3, 6. But the easy way to remember the factors is to put them in pairs. 1 times 6 is 6, 2 times 3 is 6. So if we continue out a little bit more, we can say factors of 7. Factors of 7, 1 and 7. Nothing else multiplies gives 7. Factors of 8, 1 and 8, 2 and 4. Those are factors. So 1 and 8, 2 and 4 for 8. So these are factors. All of these numbers can fit into that number without leaving a remainder. All of these numbers can fit into that. These 4 numbers can fit into 6 without leaving a remainder. These 2 numbers can fit into 5 without leaving a remainder. These 3 numbers can fit into 4 without leaving a remainder, and so on. So those are the factors. One of the ways you can remember factors is think of the letter F. F fits in. Factors fits in. So a factor, a number is a factor of another one if that number fits into the other one. So all of these can fit into that without leaving a remainder. These 2 numbers can fit into that without leaving a remainder. These 3 numbers can fit into 4 without leaving a remainder. These 2 numbers can fit into 5 without leaving a remainder. So a factor is a number that can fit into another number without leaving a remainder. What are prime numbers? Prime numbers are numbers that has only 2 factors. Prime numbers are numbers that have only 2 factors. Is 1 a prime number? No, it has 1 factor. Is 2 a prime number? Yes, because it has only 2 factors. 3 a prime number? Yes, it has only 2 factors. 4 a prime number? No, it has more than 2 factors. 5 a prime number? Yes, it only has 2 factors. 6 a prime number? No, it has more than 2 factors. 7 a prime number? Yes, it has only 2 factors. So a prime number is a number that has only 2 factors. So I want you to remember what's a prime number and what are factors. And we're going to be using that to do our factoring method. Now factoring is coming from the word factor. Okay. Let us look at how we normally do our long division. Now, let's look at when we're going to be looking at the number 442 divided by 17. First thing to note is that we're not going to be using the factoring method for this because this is a prime number. We only use a factoring method when the number is not a prime number. So this is 17 is a prime number because only 1 and 17 can fit into 17 without leaving a remainder. So it is a prime number. We're not going to be using the factoring method to solve it. So I'm going to remind you how we would do this when it's not, when it is a prime number. So first thing we're going to be doing, we're dividing by 17. So the best thing to do is to write the multiples of 17 at the side of our page. So we have 17, 34, 51, 68, 85, and we can stop there. We might need more, but let's stop there. 17, 4, 4, 2. 17 into 4 I can't. 17 into 44 goes 1, 2 times, and that 2 times is 34. I'm going to take away, and I'm having 10 left over. I'm going to take down my 2. 17 into 102. Now, I have not reached 102 yet, so I need to check if it can go further on. If I have 85 and I add 17 more to it, I did reach 102. So 1, 2, 3, 4, 5, 6. So that's going to give me 6 times. 6 times 17 is 102. Nothing is left over. So 442 divided by 17 is going to be equal to 26. Now that's how we would normally do it. Now let's look at how we're going to do the factoring method. We're going to do 756 divided by 27. Now first I'm going to be doing it the normal way, the long division way, and then I'm going to be doing the factoring method for you to see what the difference is. Now, if I was asked to divide this and I was not doing the factoring method, it means I've got to know what my 27 times table is. So it's best to write down at the side my 27 times table. 27, 54, 81, 108, 135, 162, and let's stop there for a while. We might need to go further. So 756 divided by 27. 27 into 75 is 1, 2 times. So I'm writing 2, but 2 times only gives me 54. 4 from 5 leave 1, 5 from 7 leave 2. So I have 21 there. I now need to take down my 6. So I have 216. I now need to say 27 into 216. I do not have 216 there. It means I'm going to have to continue. After that, it's going to be 189. Let's try again. And if I continue there, I'm going to get 216 right there. So 27 into 216, 1, 2, 3, 4, 5, 6, 7, 8 times. 8 times that is 216. So 27 to 756 is 28. Now let's look at how we're going to do the factoring method. How we're going to do the factoring method. Now, we know that we're going to be getting 28 for our answer, but now we're going to be using the factoring method. The first thing to do is write your 28 and find 2 factors of 28, preferably single digit. 2 numbers that multiply together to give 28. Now, I'm going to be using 28, were we dividing by 20? Sorry, 27. 27, I'm going to use in 3 and 9. I'm going to be using 3 and 9. So this is what you do. The first thing you do is to divide by one of these numbers. It doesn't matter which one you're going to use. So 756, I'm going to divide by, I'm going to choose to use 3. 3 into 7 goes 2 times, remainder 1. 3 into 15 goes 5. 3 into 6 goes 2. Now I'm going to take this 252 and I'm going to divide it by the next number, which is going to be my 9. 9 into 25 is going to give me 2 times, because 2 times 9 is 18. I'm going to be left with 7. 9 into 72 is going to give me 8, so my answer is 28. So just know, doing my single digit method and my factors, I can divide to get that. Now, let's look at another example. Let's look at 9303 divided by 21. 21 is not a prime number. So I can find 2 numbers that can go into 21 without leaving a remainder. So 2 numbers that are factors of 21. I could use 7 and 3. So because I'm using 7 and 3, now I'm going to divide by one of these first. It doesn't matter which one I'm going to be using. 9303, I'm going to divide, I'm going to be using 7 first. So if I'm going to divide that by 7 first, 7 into 9 goes 1 time, remainder 2. 7 to 23 is going to give you 7 3s 21, remainder 2. 7 into 20, 7 times 2 is 14, 2 times remainder 6. 7 into 63 is 9. Now I've used my 7, now I'm going to use my 3, but I'm going to use it with this new number. 1329 divided by 3. 3 into 1, I can't. 3 into 13 is 3. 3 3 is 9, is 4. 3 4 is 12, remainder 1. 3 into 12 goes 4 times. 3 into 9 goes 3 times. So here we have 3903 divided by 21 is equal to 433. And that is using the factoring method. Let's look at one more question. If I'm going to be doing 7230, and I'm going to be dividing that by 15. Again, all I need to find is 2 numbers that multiplies to give 15, or 2 factors of 15. I'm going to be using 5 and 3. First thing I'm going to be doing is to divide by one of these. So 7230, I'm going to choose to use 5 first. Doesn't matter which one I use first. 5 into 7 goes 1 time, remainder 2. 5 into 22 goes 4 times, remainder 2. 5 into 23 goes 4 times, remainder 3. 5 into 30 goes 6 times. Now I have my 1, 4, 4, 6. I'm now going to use the next number, which is the 3, to divide that number. 3 into 4, I can't. 3 into 14 is going to give just 3 4s 12, remainder 2. 3 into 24 is 8. 3 into 6 is 2. So I have for my answer 482 for my answer. So that is using the factoring method. Let's do one more and then we'll wrap up this one. What if I have the number 3.948 divided by 42? 42, I'm going to be using 2 factors. It doesn't matter which 2, preferably single digits, because we want to use a method of dividing with single digits. So 6 times 7 is 42, so I'm going to be using 6 and 7. Okay. 3.948. I'm going to be using 6 first. 6 into 3, I can't. I put a 0, I put back my point, and my 3 can go there. 6 into 39 is going to give us 6 times, because 6 times 6 is 36. I'm going to be left with 3 there. 6 5s 30, so I'm going to have 5 times, but I'm going to have 4 left over. 6 into 48 is 8. So I have 0.658. Now I'm going to take that and divide it by the other number, which is a 7. 7 into 0, I can't. 7 into 6, I can't, so I put my 6 there. 7 into 65 is going to give us 9, because 7 times 9 is 63, and I'm going to have 2 left over. 7 times 4 is 28, so my answer is 0.9094. 0.094. So just to wrap up what we have just done, we have looked at using the factoring method to do long division. The factoring method only works when the number is not a prime number. So if I was going to divide by 17, I would not use the factoring method, because 17 is not a prime number. So because 17 is a prime number. Because 17 is a prime number, I will not use the factoring method. So to use the factoring method, we need to find numbers, or we need to know factors of numbers. So again, if we were going to do 7230 divided by 15, I would find two numbers that multiply gives 15. The two numbers that multiply gives 15 is there 1 and 15, and there is 5 and 3. I would not use 1 and 15, because if I divide by 1, it doesn't change that number, and I will still go back to the problem of being able to write out my 15 times table. So the best one to choose is 5 and 3, because 5 and 3 are single digits, and it's easier for me to remember my 5 times table and my 3 times table. So hopefully this method helps you in your long division. Thank you very much.